Hello everyone. With this video, we are presenting our research work on how land use modifications in auto-centric communities can predict behavioral changes in mobility. Focusing on Dallas, Texas, our study utilizes a data-driven approach to understand the impact of urban planning on transportation choices. Our research is crucial in today's urban landscapes, where understanding and predicting transportation behavior is vital due to environmental and societal challenges. With behavior characteristics extracted from a synthetic population dataset and the analytical framework capabilities of the MIT NTT City Science Group platform called CityScope, we aim to understand how urban land use modifications or interventions would influence transportation preferences. The goal is to highlight how some choices could mitigate the effects of autocentric mobility.
Our simulation incorporated mobility patterns from Replica Data, which is a synthetic population trip dataset primarily originating from mobility and transportation sources, including but not limited to telecom data based on mobile phone tracking and cell network information. The dataset includes representative trips in Dallas, Texas on an average Thursday in fall 2022. For every trip, the dataset includes the trip origin and destination coordinates, the trip purpose and previous trip purpose, the mobility choice for the trip taker income and employment status, and other more data. For this research, a random forest classifier was used, which is an effective ensemble learning technique that has proven to be robust and highly accurate in handling large datasets with higher dimensionality. The random forest algorithm was selected due to its ability to handle nonlinear data and to provide important scores for each feature, thereby granting insight into the factor influencing mod choice. Using tenfold cross-validation, the random forest model achieved an average accuracy score of 0.82. Upon achieving promising results with our random forest classifier, we drove further to understanding the primary determinants influencing trip mod choice. Our findings from the feature importance analysis are visualized in the picture to the left. Two key takeaways emerged from this analysis. Origin and destination coordinates played a crucial role in mobility mode choice, aligning with urban planning principles that emphasize the impact of distance and spatial factors on travel decision. Personal and household income were critical determinants, with higher income individuals showing a preference for automobile mobility, presumably for convenience, comfort, and status associated with private car ownership. To assess how land use changes may affect mobility selection behavior in car-dependent communities, we've designed three cumulative interventions. The initial step is the introduction of housing in city centers, enabling inbound commuters to reside near where they work, within the city center. In the second intervention, we focused on the introduction of workplaces in the city core for those living there but employed in outlying areas, creating job sites for the outbound commuters. And finally, we introduced amenities and within walking distance of the new housing and workplaces, where the population could now live and work within the city center, achieving what we call the live-work symmetry. This slide presents the results of the three proposed interventions. The first intervention led to a slight decrease in car use and an increase in green modes. A significant change was observed for commuting specifically, with an auto mode usage drop from 94.3% to 56.1%, and a green mode use climbing from 5.7% to 43.9%. With the second intervention, commuter trips saw a larger shift, with auto usage falling from 92.8% to 30.9%, and a green mode usage jumping from 7.2% to 69.1%. Finally, in the third intervention, centralizing amenities led to a sharp decrease in auto mode use to 28.9% and a marked increase in grid mode use to 71.1%.
Our study underscores the critical role of strategic urban planning in promoting sustainable transportation. Although measures yielded modest gains, the combined impact of facilitating walking between work, live, and amenities was significant, particularly after amenities centralization. The implications of these findings point to potential for environmental advantages, in the form of reduced GHG emissions, as well as second-order socioeconomic advantages such as reduced travel times and enhanced life quality. Moving forward, this research paves the way for further exploration into land use policy transport modes, which may include, but is not limited to, the optimal placement of amenities, policy impact assessments, and the integration of behavioral factors, laying the groundwork for more comprehensive urban planning strategies. Thank you for your attention. Our research not only sheds light on the transformative potential of urban planning, but also provides actionable intelligence for future urban strategies in Dallas and beyond.